Okay, so this is section 2.2, I guess we'll call it. Definition of a derivative and the use of limit notation within that. So first of all, we got to talk about this idea behind a derivative. It's one of the backbones of calculus. So if you think about, I always kind of talk about if derivatives are one half of a circle, then integration, the integrals are the other half of the circle. So together they just make up calc. So together you have derivatives and you have integrals. And so we start out talking about derivatives first. So we got to kind of unpack what a derivative is. A derivative gives you the instantaneous rate of change. Okay, so it gives you the instantaneous rate of change, how fast something is changing at a specific instant. It's also the slope of the tangent line. Okay, so it's the slope of a tangent line to a graph. So you guys have only probably heard about tangent lines using, with circles, but we can also talk about tangent lines in graphs. Now, I understand that a tangent line touches a graph in one place, but it's also really only intersects a graph, and it really never crosses the graph. So what I mean by that is you might have a curve that looks like this, right? And if we were going to draw the tangent line for that, it would come in, it would touch that curve, and then it would go out the other way, and it would only touch that curve in one place. Now, I recognize that depending on what the curve looks like, if I draw a curve like this, and then I draw the tangent line maybe right here, I recognize that my tangent line could go through here, touch that curve there, and cross there. So right here is an intersection. Right here, it's tangent. So I recognize that when we talk about this idea of tangent, it's relative to some specific x value. Okay, so keep that in mind that a tangent line may cross later on, but we're really talking about at a specific x value. And the derivative just gives you the slope of it. It doesn't give you the tangent line. It just gives you the slope of it, of that tangent line. So just like in yesterday's video when I was dragging that point a little bit closer and closer and closer, and I zoomed way out and you saw that it was a tangent line, we can write the instantaneous derivative or a definition of a derivative. We could say it's the slope of a tangent. We could also use this idea of f prime of x, which that little apostrophe, it looks like apostrophe, it just stands for prime, and that's the notation for a derivative. What that's equal to is it's equal to the limit. I'm going to change mode. As h goes towards 0. So remember, I was squeezing those points together of f of x plus h minus f of x divided by x plus h minus x. So That's y2 minus y1 over x2 minus x1. Now I understand that the denominator really simplifies. If you think about how this might simplify, it would be f of x plus h minus f of x divided by h. So that's the definition of a derivative, and you have to be able to recognize it. There's usually at least one multiple choice question on the AP exam that covers that specific thing. So when we're asked to find the slope of the tangent line when x equals -1 to this thing, right now the only thing we have is this definition of a derivative. Remember that the derivative is the slope of the tangent line. So when it asks us to find the slope of the tangent line, it's really saying find the derivative. When x is equal to -1. So let's go through and show you how you need to do that today and how you need to recognize it today. What we're going to do is we're going to say, okay, then f prime of x generically is f of x plus, or sorry, the limit, write that, the limit as h goes to 0 of f of x plus h minus f of x divided by h. Now what we have to do with that is we have to use this function that we have and insert it in there and then do some simplification and use the idea that we had with limits from unit 1 to kind of talk about what do we need to, how would we evaluate it. So let's use this particular function. So let's say we're going to say, okay, well, we got the limit as h goes towards 0, and let's put f of x plus h. So it'd be x plus h squared plus 5 minus, and you really need these parentheses. If you don't have those parentheses, you'll run into an issue with subtraction because you're really subtracting that whole other function, and then that's divided by h. Now you might go, well, shoot, that doesn't look any better. Well, just wait a minute. Let's multiply things out and let's see what happens, and then let's look at what would happen if we evaluate it. So this is the limit as h goes towards 0. So this would be x squared plus 2xh plus h squared if we FOILed that first thing out, plus 5 minus x squared minus 5 all over h. Now, hopefully you kind of look at this and go, hey, look at that. There's some great things that happen. We actually get the 5s to cancel out. We get this x squared to cancel out. And now we look at this, and when we plug in 0, we end up with 0 over 0. Well, that means it's a whole, right? That we need to simplify. Well, notice what you can pull out of the top of that function right now. Out of the top of that limit, we can factor out an h. And if we do that, we have the limit as h goes towards 0, because it's still a limit. We factor out an h. This would be 2x plus h still divided by h. Great thing about that is those two reduce. Now when we put in 0, we end up with 2x. So what we have kind of determined is f prime of x is equal to 2x. So that right there is the derivative. That's the slope of the tangent line. We were asked in this problem to figure out what happens when x equals 1. So f prime of negative 1, f prime of negative 1 is equal to 2 times negative 1, which is just equal to negative 2, and that's your answer. So we're still doing these limits. We're still simplifying them the way we have, And the way we did in the analytical limits that we did back in, I think it's section 1.3, we're still doing that same thing. Take this next one. So let's look at this next one. Hopefully I'll have enough enough room to finish this, but this one is saying now write the equation of the tangent line. Just as a side note, remember that writing the equation of a line is y equals the slope times x minus, I'm going to put it x minus h plus k. And just know with that line, m is the slope, h comma k is a point. Okay, so we're going to talk about what we need for this. Well, one of the things we need is we need a point. So when x equals 5, f of 5 is equal to negative 8 times 5 squared minus 3 times 5 plus 10. And if I calculate that, I'm going to do that with my calculator. You all have a calculator. Negative 8 times 5 squared minus 3 times 5 plus 10. I end up with negative 205. So I have this point now, 5 comma negative 205. There's my point. I still need my slope. Okay, so I still need this slope. So let's talk about how we find this slope. That slope of the tangent line is the same thing as finding f prime of x. We would do that by taking the limit as h goes towards 0 of f, remember, go back to this limit, this definition. We're going to do f of x plus h minus f of x divided by h. So that's what I'm going to do down here. I'm just going to jump right into it. So I'm going to do negative 8 times x plus h squared minus 3 times x plus h plus 10 minus negative 8x squared minus 3x plus 10 all divided by h. And you might go, oh my God, that doesn't look any easier. How is this ever going to be better? It's going to be better because when we simplify the numerator, we're going to get that reduction of h, and that's going to go away. So let's look at what we have. Let's FOIL this out. Let's just take a leap of faith, kind of look at what we have. So this is negative 8. This is x squared plus 2xh plus h squared minus 3x plus 3h plus 10 plus 8x squared plus 3x minus 10 all over h. We're getting close. We're going to do one more thing here. We are going to distribute that 8 through. If we do that, we get negative 8x squared minus 16xh plus, minus 8h squared. Rewrite all this other stuff, minus 3x plus 3h plus 10 plus 8x squared plus 3x minus 10 all over h. Now let's look at what happens. We get some things that go away. Notice that we have a minus 8x, and we have a plus, or minus 8x squared and a plus 8x squared. Those go away. Notice we have a plus 10 and we have a minus 10. Those go away. Notice we have a minus 3x and we have a plus 3x. Those go away. Notice what we have left. We could factor out an h, And if we did that, this would be minus 16x minus 8h plus 3 all over h. The beauty of that is these h's go away. Now we do direct substitution. When we do direct substitution on this, we get a final answer of negative 16x plus 3. So that's our tangent line. Now we need to figure out what that tangent line slope is when x equals 5. Okay, so notice we have that now. So f prime of 5 is equal to negative 16 times 5 plus 3. If I do negative 16 times 5 plus 3, I get negative 77. And that means our tangent line, the answer to this question, remember this question asked, what was the equation of the tangent line? The equation of our tangent line then is, let's plug in y. So I got y equals the slope times x minus this value 5 minus 205. And I just used this idea up here with this equation of the tangent line. I used this point, and now I used this slope, and I wrote the equation of the tangent line, and that would be my answer. Okay, last thing that you'll have to do on this assignment is, given this function, determine the instantaneous rate of change of f at x equal 8 using the limit that you have to do. Do not simplify your answer. So let's think about what this looks like. Okay? Let's think about what this looks like, and let's say, okay, well, when x equals, remember that the instantaneous rate of change, that right there is just asking us for the derivative. Remember, the derivative notation is the limit as h goes towards 0 of f of x plus h minus f of x divided by h. Okay? So when we do this type of problem, what we're going to do is we're going to use this x value, and we're just going to insert that x value in, and then kind of go along with that function f. So we don't have to simplify it. So we're going to do the limit as h goes towards 0. We're going to do 4 times 8 plus h squared plus 2 times 8 plus h to the 5th minus 4x squared plus 2x to the 5th all over h. And then we're going to leave that just like that. We're not going to simplify it because it says I don't have to simplify my answer. So hopefully that makes sense. Give some of those problems a shot. Rewatch this video. I know that some of this notation is confusing. I think after you practice a couple of these, you will be able to do the problems.